situation given to us, will be as shown. Angular momentum of a rigid body, with respect to some point in space, is equal to the angular momentum of body, with respect to its center of mass, plus the angular momentum of center of mass of body, with respect to the point of concern. Now let us first find the center of mass of the given object. Assuming the mass of both the disks to be at their center of mass, and taking this point as reference, we can say that the center of mass of the entire system will lie at this distance from this reference point. Now, angular momentum of the entire system, with respect to its center of mass, is only due to the rotational motion of system. We know that with respect to an inertial frame of reference, or a non-rotating frame of reference, an object can have both translational and rotational motion. However, with respect to the center of mass of the object, it cannot have any translational motion. The object can have only rotational motion with respect to its center of mass. So because of the rotational motion of the disks with respect to this axis, their angular momentum with respect to this axis will be as shown. As the center of mass lies on the axis of rotation, therefore, their angular momentum with respect to the center of mass will be the same. And it will be along this direction. Now let us consider the angular momentum of the center of mass of the entire system with respect to point O. Here we can see that the center of mass is moving in a circular path like this. If we consider the tangential velocity of the center of mass to be equal to v, and position vector of center of mass from point O to be equal to r, then angular momentum of the center of mass with respect to point O will be equal to this term. Note that here v is perpendicular to r, and thus angular momentum of center of mass with respect to point O will lie along this line. However, if we consider the angular velocity of center of mass with respect to z-axis as omega dash, then we can write v to be equal to this term, where d is equal to r cos theta. Now we need to find omega dash. Let us consider this triangle, which is a right-angled triangle. Here we know this length, and this length. Therefore, this length will be equal to this term. that is, the radius of circle, in which the point of contact of this disk is moving, is equal to 5a, as we are given that the disks are rolling without slipping. Therefore, in the time this disk makes one full rotation, the length of path covered on this circle is equal to 2 pi into a. Therefore, this angle will be equal to this term. Therefore, angular speed of system will be equal to this term. Therefore, angular momentum of center of mass with respect to point O will be equal to this term. And it will be along this axis. Now, to find the z component of the angular momentum of entire system with respect to point O, we can find the z component of each of these vectors, and then add them.